Hello learners, welcome to Unacademy. My name is Mohana. I'm a physics educator here. So in today's class, we're going to learn all about friction. So let's say take any object that's near you, just keep it on a surface, or for example take a ball, okay, keep it on a surface, just give it a push, right? It will definitely cover some distance and then it will come to a stop, right? What is making that object come to rest? That is because of your friction. So we are going to learn about friction in today's class. Alright. So once again, my name is Mohana. I'm a physics educator here at Unacademy, and I have a master's degree in physics. So this is my Telegram channel, so you can follow me here. And this is the common Unacademy ICSE and ISC both channel, so you can follow this channel as well. So today's class we're going to learn all about friction. So we'll see the basics about friction. Whenever you take an object, when it slides or moves over the surface of another object, okay, a force comes into play which actually brings this object to rest. So that object is basically friction. Now in this case, let's say I apply a force to this particular block in this direction. So if I push the block in this particular direction, so the block begins to move, but it comes to rest, right? Which means there is a force, right? So if this is basically my if this is the direction of the applied force, means, okay, there is a force that is acting in the opposite direction, right? So this force that is acting in the opposing direction, which brings this object to rest, right? So this is basically called as your frictional force. So frictional force always act in the opposite direction. So just give me one more second. All right, okay. Okay, now if you look at any object when they are in contact with each other, right, what happens is they see, let's say you have some books on this on your table, any object that's on your table, okay, any objects that's actually in contact, okay. So this surface over here that you see over here, right, the surface between this book and the table over here, the molecules at that point, they have an attractive force. Now because of that, they would have a contact force acting between them. That is, according to Newton's third law, what will happen is this book will apply a force on the table and the table will again apply an equal but opposite force on the book, right? So this is the nature of the contact force. Now obviously if the table is applying force on the book is also applying force on this particular table. Now this force, this is the applied force, right? This is basically, this force is a contact force. Now if you see this contact force again can be resolved into its components. So you can resolve them into its vertical and horizontal components, right? So let's say this force has a vertical component along this direction, horizontal component along this direction and vertical component along this direction. So the vertical component over here, we call this as the normal, okay, or we call this as the normal force. Alright, and this force, if you see, balances the weight of the object, okay. Now if you see this force that you see over here, the horizontal component of this force, this is basically a frictional force, right? So this component of force is basically due to friction. So if you see, the friction is actually a component of contact force, and if this is the contact force, so contact force just comes into picture when let's say this book, right, this book applies a force on the table, so obviously table will also apply a force on this book over here, right? So that contact force, if you see, right, can be resolved into its component forces, and the parallel component over here, okay, the component parallel to the contact force, right, whichever is the parallel force over here to the contact force is called as a frictional force, right? So the friction, if you look at, very simple idea you can see, let's say you are pushing a very heavy object. Think of you pushing a fridge or something very heavy like a washing machine, okay. So initially, let's say you apply a force and the object does not even move, right? So you apply a force, there is a force applied to this particular object, okay. So it's in this direction, so we can actually say the force applied, if you see in this case, there's a force applied in this direction, right? There is a force applied, but for the force applied, the object should have moved, right? If you apply a force, the object should move. But what we see is, initially, let's say you're applying a force. For example, it's a heavy, let's say this object is very heavy, and you're applying a very small push, right? You're just applying a force and it's not moving at all. So what is opposing, or what is making that this particular object would not move? What is making sure that this object does not move from this particular surface, right? That force that doesn't make the object move from the surface, that is frictional force, right? Which means if you apply force in one direction, there is a force that is acting in the opposite direction. Okay, so this force that acts in the opposite direction, and it always this particular force acts in the tangent. Okay, one second, sorry guys, just a second. All right, so in this case what we see is, you apply the force to an object should have started moving, but no, it's not still moving. You applied a force and the object is not moving. So the force of friction which comes into play between two bodies before one actually starts moving over the other, okay, that is called as frictional force. So in this case, the opposing force that we have is basically a frictional force, and this particular frictional force we call it as static friction. Okay, so we represent it as Fs. And this friction force, if you see, it always acts tangent to the surface. Okay, and here what we see is, so this is a force that comes into picture before the object starts to move. Now apply some more force, right? You keep increasing the force that you're applying. Okay, initially you apply a little, initially whatever force you're applying, let's say just double that force, or keep increasing that force. So now if you increase the force that you applied, obviously how much ever you're increasing the force over here, the static friction will again increase as well. Okay, but at one point, as you keep increasing the applied force, the object would just begin to move. Okay, it's not completely moving, but the object has just begun to move. So this force, so you applied a force in this particular case, this is the direction of your applied force. Now for the applied force, what we are saying, the object has just begun to move. Okay, so in this case, what we see, as the object has just begun to move, that force that we see is basically a limiting force. And if you see, limiting force is nothing but a maximum limiting friction, and that limiting friction is nothing but maximum static friction that we see. Okay, so for example, let's say let's say you applied about initially you're applying about 5 Newton of force. Okay, so if you apply about 5 Newton of force, there would be a frictional force equivalent to another 5 Newton acting in the opposite direction. Because of this, the object is not actually moving at all. So this comes into picture when the object, you apply a force and the object is not moving, so it is static friction again. So this is equal. Now let's say you apply 10 Newton of force. So again, there would be a 10 Newton of static friction that is acting in the opposite direction. Now let's say you keep increasing, you increase the applied force, right? And again, static friction also keeps increasing, but the object is still not moving. Now let's say at one particular point, let's say you apply about 50 Newton. For 50 Newton that you applied, okay, there would be a frictional force again in the opposite direction, but in this case, what happens is the object starts to move. Okay, so what we see over here, this particular point, what we saw was there was a frictional force, right? Whenever you applied a force, there was always a frictional force that was developed. Okay, and frictional force always acts in the opposite direction. Okay, hi Ayush. So, but at one point the object just begins to move. Okay, that point, what we notice, the static friction that was there, right, that existed is maximum. So we just rename this term as the force that you get, okay, as the object starts to move, just begin to slide. What is that opposing force that we have? That is basically limiting friction, and limiting friction is nothing but maximum static friction. Okay, so maximum, we call your maximum static friction, so that is, okay, is limiting friction. All right, okay, now this maximum static friction, we call it as limiting friction, and to represent limiting friction, what we say, maximum static friction, but it is maximum, right? So that is your limiting friction. Now if you see, let's say you apply some more force. Now initially the object, as you applied the force, the object was at rest, so there was static friction. Then the object began to move, so what came into picture was limiting friction. Now what you do, you apply a force, and in this case what you're seeing is that the object, for the applied force, the object starts to move. Okay, for the applied force, the object starts to move, right? So see, in this case the object is covering some distance. In this case again there is a frictional force that exists, alright, but this frictional force that acts in the opposite direction that we see, and this force is basically a kinetic friction. Why kinetic? Or we call it as dynamic friction. That is, it is a force of friction, okay, it is a frictional force that comes into play when a body is in a state of steady motion over the surface of another body. Okay, so when an object is actually moving, what comes into picture is basically a kinetic friction. Okay, so what we see over here with respect to as you apply force to an object is, as soon as you apply a force to the object, okay, the object does not move at all. Okay, so what comes into picture is static friction. Increase the force that you are applying, static friction again might increase, but the object might still not have moved. Okay, now again you keep increasing the object or force you applied. For that force there is a static force that is developed, but this is again a maximum static force that we are seeing. For that maximum static force, what we see, the object just begins to move. So what we see in this case is that as the object just begins to slide across, right, as the object, if you see, just begins to move, what we have is static friction. And while the object is actually moving, the friction that comes into play in this case is kinetic friction. Alright, and so friction, if you see in all these cases, it exists. Okay, it always exists, and if you see, it's always an opposing force. So if an object is moving, and whatever is the direction of the applied force, in whichever direction the object is moving, friction will always be in the opposite direction. Okay, so we call friction as an opposing force. Now, these are the basic types of friction. So these are the basic. Let's say if we draw a graph between as we apply an applied force, what happens to the frictional force? Let's see that. Okay, let's say, just a second guys. Okay, now let's draw a graph between applied force. This is our applied force, for which for this let's see how the force of friction appears. Okay, this is a force of friction. Now what we see is, as you increase, okay, initially the object is at rest, right? You have a surface, initially you apply a force. What comes into picture is your static friction, basically because for the applied force the object is not even moving, right? You increase the force, the static friction also increases. Okay, so this keeps increasing, and at one point what happens is, you apply a force, and this particular force, for that particular force applied, the object just begins to move. Okay, so what happens? What you have is a maximum static friction. Okay, so if this is static friction, for at one point what we notice, we have a maximum force. So this is limiting friction. Okay, now after which point, if you actually, one second guys, I'm sorry, right, after which point if you apply the force, the object begins to move, and the force that comes into picture as the object begins to move is kinetic friction, right? So this kinetic friction, again if you see, static friction is increasing. At one point you have maximum static friction, which is limiting friction, after which what we have is basically kinetic friction, which comes into picture as the object is moving. So what we see over here is, this kinetic friction that comes into play is always less than the maximum static force. So if you see the static friction, over here, it's a self-adjusting force. Okay, because as you keep increasing the static friction over here, this is a self-adjusting force. Okay, and as you keep increasing the force, right, the static friction also increases. But once the object is in motion, if you see, the kinetic friction is almost the same, right? Okay, so this is basically, the static friction is a self-adjusting force. Now, okay, now if you see, what are the factors, right, on which this frictional force depend upon? All right, so let's say, okay, just a second guys. Okay, now let's say we have an object. Okay, let's say we have an object on the surface. Okay, now this, let's say you're applying a force, and for the force applied, there is a frictional force that is developed, but in this case the object is not moving. So what we have is basically a static friction, right? So here the friction force, if you look at, okay, one second guys. Okay, so here if you look at this particular static friction depends on the surface that is actually that depends on the type of surface or how polished that particular surface is. Let's say you're moving a wooden block on another very rough surface, okay, or you're taking a very smooth or a glass rod, okay, and you're moving it or you're just moving it on a granite surface. What type of a polish the surface has, right? The static friction depends on the type of the nature of this particular surface over here. But we would think that, okay, the static friction might appears as if, okay, it might depend on how much is the contact surface area it is, right? Like what is the contact surface area over here between this object and this surface over here. But the static friction doesn't depend on this particular contact surface area, okay. The surface area that in which the object is actually in contact itself might be less or it could be more. Static friction doesn't depend on it. Contrary to that, what happens is, let's say this is weight of the object, right? Weight of the object always acts downwards. So if weight is acting downwards, which means if, let's say for example, this is a table and you've kept a wooden block on the table. So the wooden block exert a force on the table means it's a contact force, right? These two objects are in contact, so there would be a normal and opposite force for this particular weight, right? If this wooden block is applying force, that is the weight is acting downwards, means the table will also apply an equal and opposite force on this block. So that is basically the reaction force that we have over here, right? So if you see this particular static friction, if you look at, they depend on this reaction force over here. So as long as the reaction force doesn't vary, for example, let's say the weight of the body, let's take mass of this particular block to be 5 kg. Let's say weight is nothing but mass into gravity, right? For example, let's say mass is 5 kg. Now let's say acceleration due to gravity, we will take it as 10 meters per second, right? So weight of the object is right now is 50 Newton. So if this is 50 Newton, okay, obviously normal reaction force that you see is actually acting in the opposite to this weight, right? If this is 50 Newton over here, if you see along the horizontal axis, what we have is we have the weight acting downwards and the reaction force, right, acting upwards over here. Okay, so from here what we can do is we can actually say that this particular R over here, okay, this force, this reaction force minus this weight is actually 0. Why? They are cancelling out each other, right? So here if you see, you can say this R is equal to the weight over here. So R is also 50 Newton over here. Till this object is 50 Newton, till this R value is 50 Newton, this whatever is the static friction value we have here, it will be constant. But as soon as, let's say, the R value from 50 it goes up to 90, as soon as this changes, static friction value also changes. Okay, now other than this, from here what we see is the force itself, the force itself act tangent to this particular surfaces they are in contact. And if you see from here, what we are seeing is that this force that we see, okay, the static friction, if you see, is proportional to the normal reaction force. Okay, meaning if to remove the proportionality sign, we can actually use this constant mu s over here. Okay, so mu s is nothing but coefficient of static friction, and it is just a ratio between your static friction by the normal reaction force. Alright, so these are the laws of your static friction. Now similar to how we have the laws of static friction, if you look at kinetic friction is when the object is moving. Okay, let's say this block is actually moving, right? As this block is moving, what the force that comes into play in this case is basically in this case what it comes into force is basically, in this case if you see, this is kinetic friction comes into picture, right, for the force applied. Now in this case, if you see again for kinetic friction, again if you see it depends on what is the contact surface. Friction itself depends on what is the type of contact surface we have over here, right, between the block and this table or whatever you're taking, right? What is the objects that is in contact with, what type of surfaces are there, how much polished they are. And then again if you see, kinetic friction also depends on the normal reaction force over here only. Okay, now kinetic force also acts tangent to the surface over here. Okay, and this depends on R value. Okay, so R increases or decreases, this kinetic friction value again changes. Now if you see, this kinetic friction is proportional to normal reaction force. Again, to remove the proportionality sign, we introduce a constant called as coefficient of kinetic friction. Okay, mu k, which is nothing but coefficient of kinetic friction, which is just a ratio between kinetic friction and the normal reaction force. Okay, so what we have is basically, we saw two more definitions. One is what is coefficient of static friction. So this depends on the ratio of limiting friction to the normal reaction force. And we saw what is coefficient of kinetic friction, which is a ratio of kinetic friction to normal reaction force. Okay, now look at this friction component, or the coefficient of static and kinetic friction. See, they are a ratio of the similar component, right? So friction, limiting friction is again, the unit of limiting friction is Newton, and if you see, obviously reaction force is also Newton, right? So if you see, the units gets cancelled, so coefficient of kinetic friction does not have any units. All right, so this guys, I'm really sorry, just give me 1 second. Alright, so till now we have seen what is static friction, what is limiting friction. Okay, maximum kinetic friction is basically limiting friction, and then we have also seen what is kinetic friction. Another name for kinetic friction is dynamic friction. From there we have seen what is coefficient of static friction, okay, and coefficient of kinetic friction. Now let's see what is angle of friction. Alright, very simple. Let's say we have a block and it's kept on a surface. Now let's say we are applying a force. Let's say a force is applied to this particular object. Let's say the force applied is F. Alright, so first, for the force applied, there would be an opposite reaction force, right? So this reaction force that we see is basically, in this case, let's say you're applying a force and the object is actually not just begins to move. Okay, we'll say it just begins to move. If the object just begins to move, then what it has is a limiting friction. Okay, now obviously in this case, if you see, the weight of the object acts downwards, right? So if weight of the acts downwards and these two are in contact, with these two objects are in contact, right? The block and this block is kept on this particular surface. Because they are in contact, there is a normal reaction force that is, I mean, there would be a normal reaction force to this particular surface as well, right? So these are the various forces acting on this particular object. We have applied a force and the object just begins to slide. Now, if you see these two forces, that is the normal reaction force, okay, and the limiting force over here, and if we take the resultant between these two forces, right? So very simple. If you're taking the resultant between these two forces, you can say these are like two sides of a parallelogram, and it would be in the diagonal joining the two. Okay. Now this is basically the resultant between the normal reaction force, okay, and the maximum static friction, right? Now if you see the angle between this reaction force and this maximum and this resultant over here, okay, this angle over here is theta, and this angle theta is called your angle of friction. Okay, now if you see, what we have over here is, let's say, this vectors, obviously we could move the vectors, right? This Fs max, what we could do, we can move it to this point over here, right? We can move this vector here. So what we have right now is basically a right angle triangle. Okay, so we have this is basically the resultant of R and F and the Fs max, right? And then we also have then we have the normal reaction force over here, right? And also if you see, we have the Fs max. So angle between all this is basically, we said this angle over here is theta. Now if you see, let's take tan of this angle. We want this side and this side of the triangle, because this is basically this side is basically the normal reaction force, and this side, if you see, it is the limiting friction, right? So if you see tan theta over here, that is nothing but opposite side. What we have is basically, in this case, we can also give it a name, right? We can go as, let's say the center point over here is O, let's say this side is B, and let's say this side is C and this is actually A. Okay, and over here obviously this is O, and what we have over here is B, and this point over here is basically right, so this point over here is basically C, right? So if you see tan theta, if you see, it would be this part BC by this side over here, right? O, the perpendicular by base we have again as OB, right? So this BC, if you see, obviously this BC is actually equal to OA over here, right? This and this side of a parallelogram are same, right? So whatever, you can actually move this vector here, or we can say this side and this side are same. So obviously this should be whatever is BC value, that should be equal to OA. So which is nothing but Fs max, that is maximum limiting force by normal reaction force. Now if you take tan of the angle of friction, we get this value, right? So what we are seeing is tan of the angle of friction, if you see, we get maximum limiting friction by normal reaction force. But this value is nothing but equal to, we just saw, this is nothing but coefficient of static friction, right? So from here what we can say, coefficient of static friction is nothing but equal to angle of friction. Okay, sorry, tan of the angle of friction. Coefficient, okay, theta is basically angle of friction, okay, and if you see this mu s in this case, if you see, what we have is the tan of the angle of friction is equal to static friction. Okay, now I'm sorry guys, 1 second. Alright, so okay, now this is angle of friction. Now so we can say the angle of friction, we can say it is nothing but, it may be defined as the angle between, okay, the normal reaction, the angle between the resultant of the limiting friction, okay, and the normal reaction makes with this particular what is the angle between the normal reaction, and if you take the resultant of limiting friction and the normal reaction, if you see this one, this vector, the resultant, and if you take the normal reaction, what the normal reaction makes with this resultant over here, this angle is called as your angle of friction. Now similar to this, we also have angle of repose. Okay, now let's say we have kept an object, okay, let's say this object has a mass m, alright, and this object has a mass m and it's kept on this particular inclined plane. Let's say the angle that we have of this particular inclined plane over here, let's say this angle is phi. Okay, now if this angle over here is phi means, okay, and let's say we are trying to, let's say we kept it on an inclined plane, and let's say we kept it on a flat surface and we keep increasing the inclined plane angle. Okay, let's say initially the block was kept like this, then we keep increasing the inclined plane angle so that the block over here just begins to slide. So if the block over here just begins to slide, then obviously the force is acting downwards, right? So if the force is acting downwards, then frictional force, if you see, the force of friction that we have acts in the opposite direction, right? So because we are saying the block is just beginning to move, what we see is a maximum static friction. Now, if this is the direction of the applied force and this is where the force is moving, and if you see normal to this surface will be in this direction, okay, that is normal between the inclined plane and the block over here, that is the contact force, right? So normal to the surface, that is the reaction force, acts in this direction, and if you see the weight of the object acts down. Weight of the object is nothing but m into g. Right, now if the weight component is acting down means this is acting at an angle, right? So this weight can be resolved into two components. Okay, so let's say we take this particular, we can resolve this particular weight component into its horizontal and in this case its vertical component, right? So let's say this angle over here is phi. So if you see this component over here, this again can be moved to this side over here, right? So we have mg acting in this direction and we have this component which is phi, okay, and we don't know what this distance is. Let's take it as x. And then we have one more component over here which can be moved. If you move this and if you turn this triangle, that is somewhere over here. Okay, so this angle, this vector vertical, again we can move it over here. Okay, so this horizontal, again we can move it over here. And what we are going to do is we have to find what is the component, Okay, so if you resolve this again, if you see this side is basically, let's take it as y over here. Okay, or in this case if you see, or we can take it, okay, any quantity that you're taking over here for this angle, if you see, let's take cos theta. Okay, cos phi in this case will be what? The resultant component, that is mg, okay, by this particular component, right? That is basically the adjacent side. Okay, I'm really sorry guys, just give me 1 second. Really sorry about that. Okay, then in this case what we have is just a second guys, I hope I'm back. Alright, so in this case again, I'm really sorry about this. 1 more second. Okay, so in this case what we end up having is this side over here. Okay, so obviously this is phi, means this will be mg, and this side over here would be basically be y. So sorry, I'm really sorry. So what we have is cos theta will be this base over here by perpendicular, right? This is by mg. So this y we are taking will be mg cos phi over here. Okay, so this side is mg cos phi, means this side is mg cos phi, means obviously this would be mg again. If you say if you take for this side, right, sin theta, if you take, it would be, in this case if you say, let's say this side is x over here, right? So if you say sin phi over here would be opposite angle, opposite over here is x by the hypotenuse mg, right? So x over here will be mg sin phi. So this side is basically mg sin phi over here. Now we have all the forces acting on this particular object, and if we could resolve these forces, right? So if you see, look, let's take at all the vertical forces, right? Here if you see, this reaction force will be equal to the mg cos phi component. Okay, and if you see this friction force that we see, right, this friction force that we see is actually equal to the mg sin phi component. Why? Because we kept the object such that it just begins to slide, right? Now if you see, now if you divide these two, let's say if you take the static friction by this, if you divide this, so on the other side what will happen? Obviously you have mg sin phi by mg cos phi. So mg gets cancelled, so what you have is this value is actually equal to tan phi. Okay, but we know maximum static friction by reaction forces coefficient of static friction, right? And if you see over here we have coefficient of static friction is equal to tan phi, but we already saw that this value is actually, alright, this value that you see is actually equal to the tan of the angle of friction. So tan of the angle of repose is equal to tan of the angle of friction. So angle of repose is equal to angle of friction over here. Okay, so with this we are, in today's class we are coming towards the end. Okay, so what we would do is tomorrow with the on the Unacademy platform we have a free class at about 7:45. So we will be covering work done by we would be basically covering the concept of work done against frictional force, right? And also the day after that, right, in the upcoming classes we also have one particular class for friction where we will be only doing numericals. Alright, you can check that out. So do that. You can go to the website and click on the free live course classes, right? You can just click on self-study. You can go to free live classes and you can check for the educator and you will get all the upcoming free live classes over there. Alright, so if you like the channel, and I'm really sorry about the in-between delay for a second, right? So if you like the channel, do subscribe, and if you click on the bell icon, and thank you for taking the class, and if you do like the class, please share it among your friends. Alright, I'll see you all in the next class. Bye.